Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from economic load dispatch. The name of a topic is method of Lagrange's multiplier, or other name is economic generation scheduling or economic load dispatch, neglecting losses and generator limit. Neglecting losses and generator limit. So both topics are same, or on the other hand we can say it is method of Lagrange's multiplier. So let me take first dark color pen. Now let us consider that there are n number of units. There are n number of units which are connected with each other or which are operating in a parallel in a plant. So let me draw this. This is your generating unit 1, this is your generating unit 2 up to, let's say there are n generating units. This is one common bus to which all the generators are connected here. Then let me draw it, the diagram, total diagram here. So let's say this will be your generator 1, G1. Power which will be generated with the help of this generator 1 is Pg1. This is your generator 2, and here the power which will be produced by this generator 2 is Pg2, and here I can write it as Png, and this will be your Gn, n number of generators we are talking about. And to this bus here some kind of load is connected, so this is nothing but PD, and here if you see the plants are connected to a common bus, so this will be a load demand. Now the cost of a generation of we can say cost of a generation of generator 1 is C1, for generator 2 it is C2, and for generator n it will be Cn. So let me write it here. What is PD? PD will be equal to what? It will be equal to a total demand, or you can say it is demanded power. Then CT will be equal to, I write it here, total cost of n units to supply a load of PD, to supply a load demand, that is PD. So how I can write mathematically? Okay, let me write it here. How I can write it? CT will be equal to total cost of generation will be what? Cost of generation of generator 1 plus cost of generation of generator 2 up to here I can write up to Cn. Or in other words, mathematically I can write it as CT will be equal to summation I equal to 1 to n Ci. Please write it this as a equation number 1, where we know that what is C1, C2, C3. This is the operating cost of generator 1, generator 2 and generator 3, or unit 1, unit 2 and unit 3. Now what is our aim of economic load dispatch? Please don't forget it. Aim of economic load dispatch is what? To minimize the cost of a generation. To minimize a total cost of a generation, so that whatever will be a demand, that much amount of at least generation should be there. Now here we are neglecting losses. That's why here I am not going to write it as plus Pn. The name of a topic is what? ELD, neglecting losses and generator limit. So I write it as equation number 2. This is called as equality constraint. Why it is called as equality constraint? Because whatever will be a demand, at least that much amount of generation has to be there. Here we are neglecting losses. So this is what is our aim, to minimize the CT, so that summation of I equal to 1 to n Pgi will be equal to PD, which is nothing but your equality constraint. Now I write this equation, I can modify this as what I will do, PD, I will shift this term towards right hand side, minus summation I equal to 1 to n Pgi, which will be equal to 0. Let me take this as a equation number A, which again it is again one kind of equality constraint only, where we know what is CT, total cost. Pgi is nothing but what? It is generation of a plant, I number of plants we can say. PD is the total demand. Now, the problem of minimization of total cost, that is CT, can be solved by a Lagrange's multiplier method. So here we are going to discuss about a Lagrange's multiplier method. Here we are going to discuss about what? Lagrange's multiplier method. This method was proposed by two gentlemen, two scientists, and the name of these two scientists is nothing but Kuhn Tucker. Kuhn Tucker. This is the paper which was published in one conference in 1953. So now what is this Lagrange's function? So I will write it as, let's say, let the Lagrange's function will be equal to, what is that Lagrange's function? C will be equal to Ct plus lambda into f. Let me take this as a equation number 3, where this lambda is nothing but what? It is nothing but your Lagrange's multiplier. Lambda will be what? It will be a Lagrange's multiplier. Now what is this f? F is nothing but a function basically. Now which function? This is your equality constraint. F will be equal to what? It will be your equality constraint, which already we have written by equation A. So what we have to write here, that is, I can write it here as, what is your f? F will be equal to PD minus summation I equal to 1 to n PGI, which will be equal to 0, which already we have seen in equation number A. Now let me write this equation. So therefore how I can write? C will be equal to Ct plus lambda into bracket f. In place of f I am going to write it as PD minus summation I equal to 1 to n PGI, which will be equal to 0. Now what is our aim? Aim is to minimize the CT, minimize a total cost of a generation. How it is to be achieved? It is achieved if we take a derivative. That is, if we are taking daba C upon daba PGI will be equal to 0, then only it is possible. So I write it as, I'll take a derivative of this expression. So it will be what? Daba C upon daba PGI, which will be equal to daba CT upon daba PGI plus daba upon daba PGI of what? Of this total term, lambda into bracket PD minus summation of I equal to 1 to n PGI, this bracket close, which will be equal to 0. So what we are going to do, why we are taking this derivative? Because we have to minimize the thing, minimize the cost of generation. Now we know that what is CT? Already we have seen CT will be equal to summation I equal to 1 to n CI. So therefore I will modify this above expression as daba C upon daba PGI will be equal to what? Daba upon daba PGI. In place of this CT, I will write it as summation I equal to 1 to n into CI plus this daba upon daba PGI. It will be as it is. I will write it as lambda into bracket PD minus summation I equal to 1 to n PGI bracket close, which will be equal to 0. Now if you see, the cost of the plant C depends upon its own output PGI. So can I write like this? Daba CT upon daba PGI. I can write it as daba CI upon daba PGI, because if you see it, the cost of each and every plant, unit 1, unit 2, unit 3, it depends on unit n. It depends upon its own output, how much power it is going to produce, and that also depends upon the load demand. So I can write it as daba CT upon daba PGI equal to daba CI upon daba PGI, which will be equal to what? dCI upon dPGI. So let me write this as expression number 4. Let me take this as expression number 4. Now what I will do, I will just do it for right hand side only. I will do, let's say, from 4 and consider RHS. Consider right hand side, that is RHS. So how I can write it here? Here, if you see, I'll take it this right hand side. So what it will be? This is your dCi upon dPgi, because please see it here, dabba Ct upon dabba Pgi will be equal to what? dCi upon dPgi. So here in this place what I am going to write? I am going to write it as what? dCi upon dPgi. dCi upon dPgi plus, now this PD is the, let's say suppose the demand is a constant, so derivative of a constant is 0. So how I can write this? Lambda will be as it is, derivative of PD with respect to Pgi will be 0, and derivative of Pgi with respect to Pgi, it will be equal to what? It will be equal to 1. So I can write it here as a 0. So from this expression I can write it as dCi upon dPgi will be equal to what? Will be equal to lambda. Please remember, this is very important thing. Mark this as a equation number 5. This is called as coordination equation. This is called as what? Coordination equation. And which coordination equation? When there is no any power losses or generator limits have been considered. So it will be what? Coordination equation, dCi upon dPgi equal to lambda. So therefore, from this above whatever equation, fifth equation we have written, when the transmission losses are neglected, so I can write it as wherever I equal to 1, 2 up to n. So what is the coordination equation? How I can write it as? dC1 upon dPg1 will be equal to dC2 upon dPg2 will be equal to dCn upon dPgn will be equal to lambda. So in other words, I can write this is incremental cost curve of first unit, incremental cost curve of a second unit, up to incremental cost curve of a nth unit, which will be equal to lambda. That is, all units should operate with equal incremental cost lambda. All units should operate with what? It should be operate with equal incremental cost lambda. So this is what is the derivation of method of Lagrange's multiplier, or in other words we can say economic load scheduling, neglecting losses and the generator limits. Thank you for watching this video. If you have any doubt, please feel free to ask. Once again, thanks a lot.